Dr. Professor U.P. Singh, a leading surgeon of Bihar, is known as best anatomist ever produced by DMCH or any college. He corrected Gray's anatomy at more than 20 places while he was a first year student. The then editor of Gray's Anatomy, Dr. Professor D.V. Davis, offered him a job of demonstrator in St. Thomas School of Medicine, London, at that very time after graduation. Though Dr. U.P. Singh declined that post of anatomist, but his lectures on anatomy is being recorded and produced for students of various faculties, as anatomy is the basis of medical science.
Where medicine ends, surgery begins. Just like where artery ends, vein begins. So, between the artery and the vein, there are certain structures. They are called arterioles and capillaries. Arterioles are just visible by the eyes. Capillaries are not visible. Capillary, the word has been taken from capillus, like here, and it has got a diameter of some micron, whereas the diameter of RBC is 7.2 micron. So it just squeezes itself in the capillary. But everywhere it is not true. At some places, the capillaries are replaced by sinusoids. Capillaries are replaced by sinusoids. Now, especially in spleen, liver, then at the tip of the nose, at the tip of the tongue, tip of the fingers, the arterioles, especially the capillaries, they are replaced by sinusoids. So that you can say that directly artery and veins are communicating. Now at places there are, when erectile tissues are there, a cavern type of structure is formed, honeycomb type of structure is formed. This cavern we have got in erectile tissue, and it happens in the clitoris in females and in the penis in males. We have got cavern, that is honeycomb type of tissue, which is full of venous blood, and that makes that tissue erect. So in erectile tissue we have got caverns or cavernous. Artery, I told you that it branches and rebranches. Just in contrast, veins, it receives tributaries. Before we start talking about the veins, you should know that what is the problem with the veins. The problem with the veins are that in artery we have got a pump. The heart pumps it so that the blood goes to the different systems. But in veins there is nothing like that. Then artery is itself capable of contracting because it has got muscle in its wall. It has got inherent capacity to contract and relax. Veins, they do not have this. So how the venous blood reaches the heart, that is one of the biggest problem. From head and neck, there is no problem because gravity assists it and there is no valve. So blood will just trickle into the heart from the upper system. But from the lower side, it is just other way. It has to antagonize the venous gravitational force, and the blood has to ascend from the toe to the heart. How it overcomes? There are certain factors. There are three things. One thing, the biggest factor is the thoracic cell. When this thing goes down in inspiration and chest wall goes out in inspiration, negative pressure is created. This negative pressure sucks the blood from the upper side, from the lower side. Okay? Second, you exhale there, the positive pressure is there. So this negative pressure is a pressure which brings the blood from the toe to the heart. Second thing, that instead of heart over here, nature has provided pumps, muscular pumps, into the peripheral extremity, especially inferior extremity. You will find that there is, when you put your foot like this, lot of pressure is created in the sole. When you are walking, what happens? The contraction of the gastrocnemius muscle creates pressure, and the pressure rises up to 200 millimeter of mercury. In the artery, the pressure is up to 120, 140, something like that. In the venous system, in the gastrocnemius muscle, the pressure rises up to 200 millimeter, or it can go even beyond that. So this pressure pushes the blood up. That is called peripheral pump. We have got peripheral muscular pump in the pterygoid muscle. We have got in the gastrocnemius muscle. So they too help. And the third thing, that the nature has made the veins a beautiful structure. In superior extremity or in the head neck, I told you that there is no valve. But in the inferior extremity, there are valves. And these valves are unidirectional. Meaning by that when the things will contract, the blood will be pushed up in the superficial venous system. And when it is contracting or when it is relaxing, the blood will not be pushed down. It won't come down because the vein shuts up. It is unidirectional valve. So the venous blood will rise up. When this contracts, the deeper venous system, the muscle of the soleus contracts. Then what happens? That pressure rises. There are perforated vessels between the superficial system of vein and the deeper system of the vein. So when pressure rises up 200 millimeter, this blood is pushed up. But the same blood will not go into the superficial system. The blood from the deeper system will go up. But the superficial system, this valve will not allow the blood. But when it relaxes, the deep venous system, when it relaxes, then what happens? Blood pressure falls up to the 20 millimeter of mercury. So from the superficial system, the blood will go into the deep system and it will ascend up. So this is the second most beautiful way by which nature combats gravity. And the third thing is that if you are a good student of anatomy, you will remember it, that all the peripheral vessels, be it radial, ulnar, anterior tibial, posterior tibial, brachial, they are with vena comitans. Vena comitans means there is an artery and the veins are small veins accompanying it, and they communicate with each other as well. So you can say that they are surrounding the artery. These vena comitants, they do two things. When I was a student in 1961-62, nowhere in the book it was mentioned anywhere. And this question I had asked to the editor of Brain Anatomy, which I corrected at more than 20 places, that why at certain places you have got vena comitants, why at certain places you have got the big veins? And his answer was that we don't know, but probably this causes a capillary action. You put a capillary, you can see a tree where the water climbs from the earth to 360 feet or 400 feet by just capillary action. You must have read it in the botany classes. So likewise, these capillaries, by dividing it into smaller vessels, then the negative pressure created in the thorax becomes much more effective. And second thing, that the artery, when it pulsates, it pushes the blood up. So these three factors together, they force the blood to go into the thorax, into the heart. With this background, we will try to see how the venous system of the different part of the body is formed. Now, as far as the venous system is concerned, one thing you should remember that everywhere there are two systems. As I was talking superficial and deep. So in the inferior extremity what happens that in artery we talk that there is arches, superficial, dorsal arch, plantar arch. So from that arches the veins start. Artery means actually artery is full of blood, but our ancestors they when dissected dead body they found that there was one type of vessel which was empty, and one type of vessel was full of blood. So actually after death, due to contraction of the wall of the artery, this becomes empty, and the vein is full of blood. So they named the artery thinking that it carries air, nothing else. So artery is a tube, hollow tube which carries air, but actually this is the lifeline of ours. So in the inferior extremity, again there are two systems. There is a deep fossa. One system goes superficial to the deep fossa, that is superficial venous system, and deep to that is the deep venous system. So superficial venous system, if this is the little toe and this is the great toe, then from the medial malleolus, the vein which arises that is called great saphenous vein. It goes up to the thigh, saphenofemoral junction. Saphenofemoral junction near it ends. And from the lesser side or from the little finger side, there is another vein which ends in the popliteal fossa. This is a small saphenous vein. A small saphenous vein. Saphena means easily seen. It is quite easily visible, seen vein. That's why it was named saphenous vein. Now, this has got this ends in the popliteal vein. There is a valve over here, which is a constant. Other valves are that not much constant, but because this has to carry blood from the lesser side, so chances of this becoming varicose vein is less. The deep system of veins consists of anterior tibial vein, posterior tibial vein. It unites along with the interosseous veins to form popliteal vein over here. Then it ascends up as a femoral vein, and then it goes toward from the external iliac vein. And this vein ends, the great saphenous vein ends in the femoral vein at the saphenofemoral junction, just one finger breadth below the inguinal ligament. So this is of very importance that it has got a valve over here which does not allow the blood to come from this side to this. Then it has got a one perforator at the ankle, three perforators in the gastrocnemial muscle, one perforator in the popliteal region, and one perforator in the thigh. Now they have been named. These are called Corocret, perforators of Mr. Corocret. This is called void perforator. The perforator in the Hunterian canal on this or the sartorius, in the region of the sartorius, in the medial side of the thigh, is called after John Hunter Hunterian perforators. So what is the importance of these perforators? During contraction, they don't allow the blood from the deeper side to come into the superficial side. Just contrast when it relaxes, when the pressure falls down, the blood goes from this side to the deeper system so that it ascends up. And when the valve of these perforators they become incompetent, we get tortuosity that is called varicose vein. It is a painful thing. This varicosity they can cause pain in the limbs, they can cause eczema, they can cause darkening of the color, and especially those ladies, it's very common in the European ladies, those ladies who wear skirts, it looks serpentine like things, very ugly things. So they want to get it out. And not only that, it can cause ulcer, it can perforate and it will bleed like hell. Now why there is change in the color? Because the superficial surface vein or superficial system the blood is pushed into the deep system. But if the valve becomes incompetent, then the blood comes into the superficial system during the rise of the pressure. So there is stagnation of the blood and rise of pressure that causes rupture of the capillaries. This rupture of the capillaries will lead to the position of RBC in the tissue. RBC will broken into hemocysteine, so the area will become dark, a fair colored lady having a stocknet type or below knee dark area gives a very bad appearance. Then there can be eczema. And there is another theory that not only that, it attracts leukocytes. These damaged vessels, they attract leukocytes and they release their photolytic enzymes. These released photolytic enzymes, they cause further tissue damage. And there is thickening of the skin, that is called lipodermal sclerosis. All these things make the person like hell. She can't walk or he can't walk. In army or anywhere, they will be discarded. So they will, why they wear, must have seen that the thing, wear stocknet-like thing, especially those who are in standing duty, just to support the legs. And once the things becomes bad, typically a small varicosity we can inject. If there is a big varicosity, usually we strip, or nowadays we have come to the stage where you can repair the valve, or you can put an angioscope or a wire, and by hitting you can allow it to get it contracted. But once the valve has been damaged, once the venous system has been damaged, it is damaged forever. So this is the venous system.